So, after Saturn, the next one up is Uranus. Now, one immediate difference between Uranus and Saturn, even though Uranus is also a gas giant, Uranus is blue, whereas Saturn and Jupiter are more of a light orange, yellow, cream type colors. Uranus is blue. That's due to a slightly different composition, causes it to look blue. Uranus is also significant for having an axial tilt that's almost sideways. Right? Uranus also has rings, and they go like this, which is pretty wild. So basically, the way Uranus rotates, the sun might rise in the north and set in the south, or the reverse. I don't remember which, but anyway, it's pretty wild. Now you might be wondering, why did this happen? And we don't know for sure, but this definitely doesn't just happen on accident, right? Something caused this. Maybe something hit Uranus early on, hit like its core, knocked it sideways. Maybe something really massive went by Uranus and gravitationally like pulled it sideways. Something like that. Something caused it. We don't have a super great answer what yet. But people are still thinking about it for sure. Uranus also has several moons. I don't think, none of them are really particularly important. Then we have Neptune. Neptune's also blue, very similar to Uranus in a lot of ways. Not a lot to say about Neptune. Both it and Uranus are a great deal smaller than Jupiter and Saturn. Like, they're big, but they're only about maybe 4 times Earth's radius, something like that. If I recall correctly, I might be wrong. Which is big, but, Jupiter and Saturn are, hundreds of times Earth's radius, I believe. So Uranus and Neptune are a great deal smaller than Jupiter and Saturn. Yeah. Okay. Oh, another thing. It can be hard to remember whether Uranus or Neptune comes first. The way I remember it is Sun, Saturn, Uranus, Neptune. Helps me to remember that Uranus is closer to the Sun than Neptune is. Alright, so outside of Neptune, we next have the Kuiper Belt. This is a Y. The Kuiper Belt is spelled with a Y. The Kuiper Belt's kind of like the asteroid belt, except that instead of having a bunch of asteroids, it has a bunch of Kuipers. That's a joke. It does not have a bunch of Kuipers. Kuiper is the name of the person who discovered it. It has a bunch of comets. Comets are kind of like asteroids in that they aren't planets, and they, there are a lot of them. But comets are different from asteroids in what they're made of. Asteroids are mostly made of rock or metal, but comets are mostly made of water ice, with a little bit of maybe rock dirt on it, but mostly ice. Comets also tend to have really eccentric orbits. like a highly elliptical orbit that starts way out in the solar system and comes in and gets really close to the sun before shooting way back out. Not all comets do that, but a lot do that. Certainly a lot more than asteroids. Now, the Kuiper Belt's a big place, has a lot of stuff in it. The most significant, well-known Kuiper Belt object is Pluto. Pluto, as is well known, used to be considered the 9th planet in the solar system. But, for the same reasons I was talking about Ceres, Pluto is part of the Kuiper Belt. It has not gravitationally cleared out its orbit of other stuff, so Pluto got demoted to being considered a dwarf planet. Pluto, in terms of composition, it's a Kuiper Belt object. It's a lot like a really big comet. It's very similar composition to comets, but it's also got a lot of other stuff going on. It's pretty interesting. I'm not going to go over all that right now. But yeah. It's big enough to crush itself into a sphere shape. And it has a moon. It's got like 4 or 5 moons. It's got one really big moon, Charon. Earlier I mentioned that Earth's moon was the second biggest relative to the size of its planet. Charon is the biggest. Charon is something like almost half Pluto's size. It's massive. And it's so big that their gravity is so close that Charon doesn't even really orbit Pluto. They both orbit a point between them. Technically, this is how all orbits work, and I'll get to that a couple weeks down the line in terms of like the schedule. I've already done it in real time, but for Pluto and Charon, the effect is so strong that yeah, they're really orbiting a point between them. There are a couple other dwarf planets in the Kuiper Belt, like Eris is a pretty well-known one. There are a few others. Outside the Kuiper Belt is the Oort cloud. The Oort cloud is a lot like the Kuiper Belt, in that it's made up of comets, but it's much bigger than the Kuiper Belt. It's not a belt, right? It hasn't formed into anything even close to being like a nice ring. It's just a cloud. It's all around. It's further out, of course, and a lot sparser. Like, the Kuiper Belt's sparse. The comets are spread far apart, but Oort cloud is sparser than sparse. And then, beyond the Oort cloud, is the heliopause. If the Oort cloud is sparser than sparse, the heliopause is sparser than sparser than sparse. Like, there's practically nothing in it. A very few things mixed out there, but basically, it's part of the solar system because if there was stuff there, it would probably be in orbit around the sun. But yeah, not a lot in the heliopause. Now, this drawing isn't even remotely to scale, but if I was even trying to make it a little bit to scale, I couldn't draw the Oort cloud or the heliopause on here. Like, if you see a scale drawing of the solar system that includes the Oort cloud kind of makes the rest of it look tiny. It's so huge. And then the heliopause makes the Oort cloud look tiny. It's massive, and it's a sense of scale that I really can't give you. Look it up if you're interested, but other than that, I think that about covers the solar system overall. So now I think I'm going to talk about life.